Hello everyone. In this question, it is asked that if a plus b plus c equal to 1 and a, b, c are all positive real numbers, then we are to find the greatest value of a, b square, c cube, and we are also to find the values of a, b and c for which the value is greatest. Value of a, b square, c cube is greatest. Okay. So usually these greatest and least value questions, usually these require some inequality such as am greater than gm, etc. Okay, so first of all, that am greater than gm inequality holds only for positive real numbers. Okay, so we are already given that condition. So firstly we are given that a plus b plus c, the sum is equal to 1, and a greater than 0, b greater than 0, and c greater than 0, which are positive real numbers. Okay, now if we look at a, b square, c cube, okay, if we resolve them into individual terms, the product will be like a times b, since b square, times c times c times c. Okay, so there is a single a, 2b, and 3c for this expression a, b square, c cube. Okay, now we are given this value a plus b plus c equal to 1. This is a condition we are given. Okay, so how can we use this concept that there is 1a, 2b, and 3c? How can we use this concept in this equation? Okay, so if we can use this concept, we can use the inequality. Okay, now if we are to find this a, b square, c cube, okay, firstly we have to try these combinations of this a plus b plus c. Okay, this combination we have to find that if we split the terms in such a manner that it gives us this product when we multiply this product of a, b square, c cube. Okay, then we can use this condition while trying to find the greatest value of this. That is, what I want to say is, from this equation we have to find 1a. Okay, from this expression we have to find 2b's, and from this c we have to find 3c's. Okay, or at least partition them in a manner such that we can get these 3c's from this equation and use this condition of a plus b plus c equal to 1. So that can be done if we rewrite this as a plus, if we divide this b into the following two parts as b by 2 plus b by 2. Okay, half plus half, right? If we sum this we get back b, right? But now this is divided into two parts. So when we multiply this b by 2 times b by 2, at least in the numerator we get b square. Okay, we have to find at least a b square. When we multiply a times b by 2 times b by 2, we get at least a b square, right? Similarly, from c, if we rewrite this as, we have to get three partitions of c, right? So if I rewrite this as c upon 3 plus c upon 3 plus c upon 3 equal to 1, this condition is still valid, right? If we sum this, we still get a plus b plus c equal to 1. Okay, so since these are real numbers, if I divide them by 2 or 3, these will again be real numbers, right? So I can now use the am greater than gm condition. Okay, I did this because if I multiply this a times b upon 2 times b upon 2 times c upon 3 times c upon 3 times c upon 3, okay, we see that in the numerator there is a single a. The product of two b's will give us b square, and product of three c's will give us c cube. And in the denominator we have 2 square 4 and 3 cube 27. So product is 4 times 27 is 108. Okay. So at least we get this numerator, right? A b square c cube, we get this. If we partition this, we can get this. So let us now try to use the am greater than gm inequality. Okay. Since these are real numbers, we can use a b by 2, comma b by 2, comma c by 3, comma c by 3, comma c by 3 are all positive real numbers. Okay, so this will imply that arithmetic mean of these numbers a b by 2, b by 2, then c by 3, comma c by 3, comma c by 3 will be greater than or equal to the geometric mean of all these six terms. Okay, six numbers b upon 2, comma c upon 3, c upon 3, and c upon 3. Okay, so this implies that a plus b upon 2 plus b upon 2 plus c upon 3 plus c upon 3 plus c upon 3, this entire thing, there are six numbers, so this is divided by 6. Okay, this will be greater than the sixth root, and the product will have six terms, right? So this will give us this. I have done the product a times b upon 2 times b upon 2 times c upon 3, c upon 3 times c upon 3 times c upon 3. Okay, so this product will give us a b square c cube upon 108. Okay, now this a plus b by 2 plus b by 2, this becomes b, right? And this becomes c. So I can use this a plus b plus c equal to 1. Okay, like here a plus b plus 2 plus b plus 2 plus c plus 3 plus c plus 3 plus c plus 3 equal to 1, right? So I can use 1 here. So this will become 1 upon 6 is greater than the sixth root of a b square c cube upon 108. Okay, so if I raise both sides to the power 6, this will become 1 upon 6 raised to the power 6, and the root will go away, and this will become a b square c cube upon 108. Okay, so we have almost completed the sum. This implies that a b square c cube, on changing sides, it will become 108, and 6 to the power 6 can be written as 6 square times 6 to the power 4, right? Now 6 square is how much? 36, right? And this is 3 times 36, 108, right? So we have 3 upon 6 to the power 4. So this can be further simplified to a b square c cube is less than 3 times 6, and 6 cube is 216, right? So this will go and 2 times. So this implies that a b square c cube will be less than your 2 times 216 is 432. Okay, so this is the maximum value. Okay, therefore greatest value of a b square c cube is your 1 upon 432. Okay, this is the greatest possible value of a b square c cube when these are real numbers and a plus b plus c is 1. Okay, now we have to find abc for which this is greatest. Okay, this is the greatest value. Now we have to find the values of abc for which this is largest. Okay, so for that case, we were given a plus b plus c was 1, and we use the numbers as a comma b upon 2 comma b upon 2 comma c upon 3 comma c upon 3 comma c upon 3, right? These were the six numbers used for AMGM, right? So if I try to equate a as a equal to b upon 2 and this equal to c upon 3, and I back substitute in this equation, from this equation I get b is 2a and I get c is 3a. Okay, now on back substituting here, I get a plus 2a plus 3a is 1, right? So this implies 6a is 1. So this will imply that my a is 1 upon 6. Okay, So this implies b is 2 upon 6, that is 1 upon 3. Okay, and this implies c is 3 times 1 upon 6, that is half. Okay, so these are the three values of ABC. And we can also check this product now, ab square c cube, with these values. A is 1 upon 6, b square is 1 upon 3 whole square, and this is half times cube, right? So this gives us 1 by 6 upon 1 by 9 upon 1 by 8. Okay, so this gives us this 1 upon 6 times 9 times 8 is 72, right? So this will give us 72 times 5 is 360 plus 72, this is 432. Okay, so this value, this 1 upon 432 value, this is what is the greatest value that we got using the am greater than equal to gm inequality. Okay, so this is the final answer, and this is happening whenever this a is these values, abc takes these values. Okay, the equality, this equality holds if am and gm are same, that is they are equal. Otherwise the arithmetic mean will be greater than that. Okay, so the greatest value of this is 1 upon 432, and the equality condition gives us these values of a, b, and c. Okay, and we can verify that when we take these values, the value of a, b square c cube is actually 1 upon 432. Okay, so this was a sum from it was used from arithmetic mean, geometric mean inequalities. Okay, so this is it. Okay, you can pause the video at any step if you have any doubts. Okay, so this is it. Thank you.